Hello students, now we're going to see some more question related to transition element. The question is copper in which oxidation state is a transition element? Suppose if this question comes, you have to do the rough work. So symbol of copper is Cu. Atomic number you should remember it's 29. And when you make the configuration, you start with argon as I said earlier in my past video, then you write 4s and 3d. Argon means 18, you know that, and 2 in this makes 18, 19, 20 with 9 makes it 29. So 18 for argon, 19, 20, 29, the configuration of copper. But as I said you, this is wrong because this d orbital is neither full fill nor half fill. So this is the wrong configuration for copper. Then what will be the right one? Right one will be like this. You make argon, you make 4s and 3d. Then what you have to do? One electron of 4s, give it to d. When you do so, it will become 4s1, 3d10, and now this became full fill, this became half fill. So this is the correct structure of copper. And copper exists in two oxidation states. One is +1, which is called cuprous, and the other one is +2, which is called cupric. So these are the two oxidation state of copper. +1 is cuprous, +2 is cupric. Now this is normal copper. Okay, this is normal copper. So how to make it cuprous? That means +1 means you have to remove one electron, and that electron you remove from 4s. So if you remove electron from 4s, that one electron, what remains here is argon. Then comes is your 3d10. 3d10. One electron gone because of +1. Now how to make it cupric? This is cupric. Cupric. So C-U-P-R-I-C. Cupric. And to make it cupric, it's +2. That means you will further remove one more electron. Further remove one more electron from here to make it +2. So the configuration becomes argon 3d9. So from copper, if you remove one electron, it becomes cuprous. If you remove one electron, it becomes cupric. But first you have to remove electron from 4s, then from 3d. Now if you see here, d orbital is completely filled, it is not transition. In cuprous also, 3d orbital is completely filled, it is not transition. Whereas in cupric, 3d orbital is neither full filled nor half filled. 1 to 9 is transition. So therefore, this is transition. So the answer for this, in which oxidation state copper is transition, means in this case, so answer is +2. In +2 oxidation state, copper is transition element, and +2 means in cupric. It is a transition element because d orbital is not completely fulfilled. Hope so you all understood. Now we go to the next question. Take the screenshot to make the notes. So answer is +2, that is cupric. Another objective question from here is this one, students. Pick the odd one out and give reason for your answer. Okay, and these are the four options given. Now many will do very simple calculation here. Copper +2, zinc +2. Zinc no charge, copper no charge. So +1 seems to be odd here because there is no zinc +1. So many will take this as the answer, but it is wrong. So what you have to do is the configuration again. Okay, now zinc atomic number is 30. So when you make the configuration, write argon again 4s and 3d, 18, 19, 20 plus 10, 30. Now zinc is 30. This zinc is 30 here. Now zinc 2 plus, when you make it, you have to remove 2 electrons. And as I said you, when you remove the electron, first you remove from 4s. So remove 2 electrons from 4s, then what remains? 3d10. So now if you check here, zinc 2 plus is completely filled with electron. It is not transition. Zinc d orbital is also completely filled with electron. It is not transition. Now in case of copper, if you see copper, here is this one. D orbital is completely filled. It is not transition. Cuprous +1. D orbital is completely filled. It is not transition. Whereas in copper 2 plus, D orbital is not completely filled. So it is transition. So here D orbital is completely filled. Here also D orbital is completely filled. In zinc case also, D is completely filled, but only in cupric case D orbital is not completely filled. So in this all, the odd one is what? Cu2 plus is odd. Why it is odd? Because it is the only transition element in the option. This is the only transition element in the option. The rest all are not transition elements. Hope so you understood till here. Now we will see one interesting question here. Cuprous are more stable than cupric salt, explain. So again you take the help of copper. Copper atomic number is 29, argon 4s, 3d you make. You know the configuration of copper now, so 4s will be 1, 3d will be 10. Now when you make it cuprous, that is +1, you have to remove one electron that you remove from 4s. So it becomes simply 3d10. And to make it cupric, you remove one more further electron and this will become 9. So this is copper, cuprous, cupric. Now, which is more stable? They are saying cuprous. That is, this is more stable. Why? Because 3d orbital is completely fulfilled and stable. Those who have completely filled d orbital, they are more stable. But in cupric, d orbital is not fulfilled, so it is not stable. So in case of cuprous and cupric, do remember cuprous salt are more stable than cupric, because in cuprous salt, 3d orbital of copper is fulfilled and stable. Since in cupric salt, 3d orbital of copper is fulfilled and stable, due to which it is more stable than cupric salt, we say. You can take the screenshot to make the notes. Similar type of question may come in this case also. Ferric salt is more stable than ferrous salt, explain. And ferric salt can be replaced with FeCl3, and ferrous can be replaced with FeCl2. This 2 is the valency of ferrous, this 3 is the valency of ferric. Now in this question also you have to take the help of configuration. So make iron. Iron is Fe, atomic number 26. So we need the configuration: argon 4s3d, 18, 19, 20, 26. Now to make it ferrous plus 2, you have to remove 2 electrons. You remove from here. 2 electron removed, so 3d6 will remain. And to make it ferric, you have to remove 1 more electron. So now you removed 1 electron. Now if you see here, in ferric salt, iron 3d orbital is half filled, due to which it is more stable than ferrous salt, because it is neither fulfilled nor half filled. So do remember, in ferric salt, that is in FeCl3, 3d orbital of iron is half filled, due to which it is stable than ferrous salt, that is FeCl2. So student answer is here: in ferric salt FeCl3, 3d orbital of iron is half filled and stable, due to which it is stable than ferrous salt, that is FeCl2. Hope so you all understood. These two are also important question. Now we go to the third one. Again, this question has come in your board exam. Okay. And the question says Mn2 plus are more stable towards +3 oxidation state than Fe2 plus ion, explain. Now you have to remember manganese and iron here. There are two elements given. So manganese atomic number is 25 and that of iron is 26. You have to remember. And they come on a 3D series. So you write argon 4s3d, argon 4s3d. Argon is 18. So s orbital 2, 20 plus 5, 25. Now here argon 18, s2, 20 plus 6d, so 26. So this is normal manganese and iron. Now if you want to make Mn2 plus, you have to remove 2 electron, and that we remove from 4s. So remove 2 electron from 4s, what remains? 3d5. Now if you want to make it Fe2 plus, because it is 2 plus, you remove again 2 electron from 4s, so it becomes 3d6. 2s is electron of 4s is removed. Now can it become +3? No. Why? Because its 3d orbital is already half filled and stable. 3d orbital is already half filled and stable, therefore it never exists in +3 oxidation state, because it is already stable here. 3d orbital is half filled. So therefore Mn2 plus is more stable towards +3 oxidation state, means it does not show +3 oxidation state. Reason, as it goes to the +2 oxidation state, d orbital becomes half filled and stable, therefore it will not lose the electrons. Whereas in case of Fe2 plus, you can see this d orbital is neither fulfilled nor half filled, therefore it can lose 1 more electron to become ferric, to become stable, half filled and stable. Therefore it can form +3 oxidation state, but it does not. So the answer goes this way, students. In Mn2 plus, 3d orbital of manganese is half filled and stable, you can see here, due to which it will not lose further electrons, and hence it is stable towards +3 oxidation state, means it does not show +3 oxidation state. Whereas in case of ferric, if you see here, a +3 oxidation, in +2 oxidation state, 3d orbital is neither fulfilled nor half filled, due to which it can lose 1 further electron to become stable and exist in +3 oxidation state. So this is also a very important question, students. So if you want, you can take the screenshot. This is the question, and here is the answer for it. Hope so you all understood. Now in my next video, students, we are going to learn is about magnetic property. Okay, we are going to learn about magnetic property of d block elements in my next video. Thank you very much, students.